Hi everyone. So we're going to be talking about domain and range today. The domain is a fancy word for all of the x values in a function. And then the range is a fancy word for all of the y values. So if I say find the domain, I'm actually asking for all of the x values. Then if I said find the range, I'm actually asking for all of the y values. And then the other thing that we're going to talk about in this self-check is whether something is a function or not. And something's a function if all of the x's are different. So the x's have to be different. Or it has to pass the vertical line test. So I'm just going to say vertical line test, and we'll talk about that in a second. So for all of these examples, what we're going to do is find the domain, find the range, and then decide if it's a function or not. So let's go through the first example. We have a list of x's and y's, and so this makes it really easy to find the domain and the range. The domain would be just all of the x values. So I'm going to say -5, -4, 0, 3, and 7. And then the range is all of the y values. So the range would be -5, -4, -1. We don't have to write -1 again because it's already happened, and then 1. So those are my domain and range. Now we have to decide if it's a function. And it's a function if all of the x values are different. In this case, all of the x values are different. So we can say, yes, it's a function. Yes, function. So it didn't matter that some of the y values are the same. We don't care about the y's. We only care if the x's are the same. All right, let's look at the next example. So this is, again, just another way to represent something. It's a relation, we like to call it, which may or may not be a function. So let's start with our domain. And if you remember, your domains are your x values, right? So your x values, it's easier to see on your graph on your example sheet, but you're going to go through the x values and list them off. So I'm going to start from the very left. My very left point is this one right here, which happens to be at -7, -2. So I only care about the x portion of that, which is -7. Then my next one, my next leftmost one is that one, which would be at -6 for the x value. Then we have these ones that are right on top of each other, and they're both at -1. So we only have to put -1 once because it happens twice. We just have to write it down once. And then the last one is this guy right here, which happens at +1. So there's my domain. Now let's do the range. The range, same thing. I'm going to do my y values. So I'm going to start with the very bottom y, which ends up being this guy right here. And that happens at -4. And then we would have this one again and this one, which both happen at -2. We only have to write it down once again. Then we have this guy right here, which happens at 0. Remember, I'm only looking at the y values in this case. And then I have this guy again, which happens at 5. So there's my domain and my range. Now, to determine if it's a function or not, we talked about something called the vertical line test. So in order to use the vertical line test, what we're going to do is draw a vertical line, an up and down line, anywhere on the graph, and if it ever hits more than one point, then it's not considered a function. So I'm going to do this in a different color. If you notice right here, if I drew a vertical line right here, it would cross those 2 points. This point right here, and then this point right here. Because it crosses 2 points at somewhere, then it is not a function. So I'm going to say, let's see, let me change my color back. I'm going to say no, not function, because it did not pass the vertical line test. All right. Now let's look at the third example. In the third example, it actually tells you the domain and range. And so that makes it really easy. Your domain's on the left side, which would be -7, -2, 0, and 7. And then your range would be on the right side, which is -7, -5, 1, and 4. Now, where we have to really pay attention is if it's a function or not. Now, we said that all of the x's have to be different, or it has to pass the vertical line test. This is another way to represent a relation with these arrows. And the way you want to think about it is if you have two arrows pointing off any one of the domains, then it's not a function. So if you look at this -7 right here, you've got one arrow pointing to the 4 on the very bottom, then you have another arrow that's pointing to the 1. So because that -7 on the domain side has more than one arrow pointing out of it, then it is not a function. I'm going to say not function. All right. Now this last example is another graph, but in this case we don't have just points. It's not considered discrete, it's considered continuous. And so when we are dealing with continuous relations like this, when we're doing the domain and range, we have to use what we can use a couple of different things, but I'm going to have you use something called interval notation. Now you have notes on interval notation, but what I want you to understand is that I use brackets when the value is included, and then use parentheses when the value is not included. Let me show you what I mean. So for the domain, we know that it's the x values. And instead of just listing a bunch of points off right here, because these, like, if you were going to list off a bunch of points right here, you would go on infinitely. Because these arrows go, like, because of these arrows on the end, what that tells me is that the graph, the line will go off the graph that I can make. It goes further and further left, it goes further and further right. And so it would be really hard to just list a bunch of values for the domain. Instead, what we're going to do is, the way that you want to think about it is the very leftmost x to the very rightmost x for the domain. So in this case, the very leftmost x, because it just continues to go left and left and left and left, is -infinity. Because it's, again, we can start from -infinity and then keep on and then move forward. And the very rightmost x, because of the arrow, would be +infinity, because it keeps on going right and right and right and right. Now, these infinities are never included because we don't actually know what infinity is, and so we put parentheses around both of them. Okay. Then and that would be considered our domain. Now what that tells me is that the domain goes all the way from -infinity to +infinity. Now let's talk about the range. The range, instead of thinking about it as just a bunch of y points, we're going to think about it the very bottom y to the very top y. So the very bottom y, or the lowest y that blue graph hits, is at -5. So I'm going to write -5 right here. Then we put a comma, and now we're going to write the highest y. Because of the arrows, that graph will continue to move up and up and up and up, which means that it would be +infinity. That's our highest y. Now, like we just talked about, infinities are not included, so I'm going to put a parentheses right by the infinity sign, but that -5 right here down below is included. There's no open dot, and in your notes it also tells you this. An open dot is not included, and a closed dot, or if you don't see any open dot, it would be included. So because that -5 doesn't have any open dots, that means that it's included, which means we're going to use a bracket. You can use a combination of brackets and or parentheses. So there's your domain and range. Now we have to decide if it's a function or not. When you see a graph, you want to use the vertical line test. So the vertical line test, once again, says that you have to draw a vertical line and it can only hit once on the graph, anywhere that you draw a vertical line. So I can draw a vertical line right here, I can draw a vertical line right here, I can draw a vertical line right here, and it's only going to cross that graph once, which means that that graph has to be a function. So I'm going to say function. And there we have it. How to determine domain, range, and functions.